Hi, my name is Bob Swanson, astronomy instructor at Itawamba Community College in Tupelo, Mississippi. Just a few days ago, a friend of mine, Noah Kearns, contacted me and said that he wanted to replicate Eratosthenes' method for determining the circumference of the Earth. He wanted to use it as a math project for his students at Mitchell High School in Mitchell, Indiana. Well, here's what we did. Remember, our job is to create a shadow and then measure the length of that shadow. Materials are pretty straightforward. You just need a level, a nice straight pole or a stick, a hammer, and a tape measure. Then the first thing is to make sure that you've got a nice level patch of ground to work with. Now it's time to grab that stake or stick and make a gnomon. A gnomon is an object that by the length of its shadow serves as an indicator of the time of day. Pound your stake or stick into the ground. Make sure that it is perpendicular to the ground. I use my level. You can also use a plumb bob, or you can be smart, like the students at Mitchell High School in Indiana, and use a nice lab stand and a nice level piece of sidewalk. When it's local noon, it's time to take measurements. You want to measure your shadow from the base of the gnomon to the end of the shadow. And of course, don't forget to measure the height of the gnomon as well. Before we get into the math, I'm just going to review what we've done. So let's go ahead and just draw the Earth here. There's the equator. Here's the Tropic of Cancer. Here's the Tropic of Capricorn. We stuck poles in the ground in Tupelo and in Mitchell, Indiana. And of course, we've got the sunlight coming in. We essentially treat sun as being parallel rays of light. And so that light casts shadows in both locations. And we would expect, with Mitchell being farther north, we would expect a longer shadow being cast in Mitchell than in Tupelo. And the angle that we're really interested in is this angle right here. And so that's what we're going to next calculate. Okay, saddle up for some trigonometry. Here's the gnomon from Tupelo, and here's the shadow. Here's the gnomon from Mitchell, and a slightly longer shadow. Just going to draw it out. And the important angle we're looking for is this one right here. I'm going to call this theta t for Tupelo. And this one I'll call theta m for Mitchell. Now the way you get the angle is we use the tangent function. The tangent of theta is going to be the opposite over the adjacent. Opposite over adjacent. So in this case, in the case of the theta here, there's my opposite. That's the length of the shadow. My adjacent is right here. That's my adjacent, here's my opposite. And so we do that for both of the both locations, Tupelo and Mitchell. And in order to solve for theta, of course, we have to take the arctangent function. So to get theta, it winds up being the arctangent of the opposite over the adjacent for each of the locations. And it turns out that the angle in Tupelo was 52.6 degrees, and the angle in, Tupelo, the angle in Mitchell wound up being 56.2 or thereabouts. To find the distance between Mitchell and Tupelo, I used a handy-dandy distance calculator from the National Hurricane Center. And there's plenty of different tools that you can find online. What I did was I just pretended that Mitchell and Tupelo were at the same longitude. So really all that matters is the latitude difference. So for our friends in Mitchell, they are at 38.73 degrees north, and in Tupelo, the latitude is 34.26. And we just compute, we're going to do it in kilometers, and hit compute. And it's 497 kilometers. Okay, so those two angles we just measured, one was theta m, and the other one was theta t from Mitchell and Tupelo. The difference between those two values was about 4.4 degrees. That is the vertical angle. We'll just call it theta. And the rest is just math. We just take a ratio. The circumference of the Earth divided by the distance between Tupelo and Mitchell is equal to 360 degrees, a full circle, divided by the vertical angle we just calculated. So therefore, we know the distance was 497 kilometers. We know 360. We know the vertical angle is 4.4, and we're just going to cross multiply to get the circumference of the Earth.